Alright, the problems below, we review how to solve some basic equations. First, write the inverse operation used to solve each of the following equations. Then show the steps used to solve the equation. Show all work. Alright, so let's show what we did on this though. So we use the T model and we'll subtract 3 from both sides. So that gives us a zero pair and we got this x equals 4. And that would be A. Now, the problem with this is a lot of people stop there, but you guys really should check these. 4 plus 3 equals 7. Because if it's false, then you did it wrong.
Mr. Sai, you did an excessive amount of work for 4 plus 3.
Check. Alright. So on B, we don't want a negative 3x, we want a 1x. So for both sides, we're going to divide both sides by negative 3. And that gives us 1 right there, the coefficient of x, and 18 divided by negative 3 is negative 6. Bam. Alright, see, this one's very similar to A. So we'll split this up. I don't want x minus 6, I just want an x. So I'm going to have to add 6 to make that a 0. But if I do it to one side, I got to do it to the other side as well. And this gives me negative 8.
I know what x is. It's negative 8.
Alright, D. On this one, we don't want x divided by 7, we just want 1x again. So to do that, I got to multiply both sides by 7. That gives us the 1 there. 3 times 7 is 21. Number 2 here, what does an inverse operation do? It kind of undoes the values, but really, for the most part, we're just trying to get the coefficient of x to be 1, so 1x. Or we want to get zeros out of all the other values, okay? Because in the equations, so we're not so worried about inverse operations as much as trying to get these 1s and zeros. Like if you had a 3x, we don't want 3x, we want a 1x, so you divide it by 3, and you get 1x. Or if you had, like in that last example, something like x plus 10. We don't want x plus 10, we want x plus 0. So to make this x plus 0, we would subtract 10. Now usually there's 2 sides to an equation, so you're doing it to one side and the other side to get either the 0 or the 1. So we're not so concerned with the inverse operations as much as the 0. I guess it is the inverse
Do you have to write the 1?
property of 0. A 0 property of addition or subtraction. Or the multiplicative or, well, I guess it is the multiplicative identity. Because anything divided by itself is 1. And anything subtracted from itself is 0. Alright, so number 3 here. Write an equation then solve to find the length of a square with an area of 25 centimeters squared. So we already know that we're trying to find the side length on this thing, and the area of the square is the same as the side length squared. So if we wanted the side length, we'd have to take the square root of both sides, which would give us just the side length. So to find that side length, we got to take the square root of the area. But we know the area on this one is 25, so we can fill that in. So yeah, well, not necessarily 5.
5 centimeters.
5 centimeters, yep. Square root of 25 is 5 centimeters. But that is the equation, and that's how that's going to work on that. So we know the side length squared is the area. Take the square root of both sides. Now you just have the side length, but you still have the square root of that area, which we know. Alright, then now consider the equation x squared equals 25. Out of context, so we're looking at this abstractly, meaning that we want some number multiplied by itself to give us 25. Well, we know 5 times itself is 25, but is 5 the only solution?
Yes.
As it turns out,
No.
it is not.
Knew it.
So 5 times 5 is 25, but then what other number multiplied by itself is also 25?
25 times 1.
Well, it's got to be multiplied by itself though, right?
5.1.
So if we think about it, these, Yeah, we already know 5 times 5 is 25. But we don't usually think about this. 12.5 times 12.5 is very big. That's okay. So then that's what we would do normally. We'd divide by 2, maybe we find factors like 1 and 25. But,
Oh, -5 times -5.
yeah, if we look at the negatives, that's very good. -5 times -5 is also positive 25.
I understand.
So 5 is not the only solution.
But you can have negative measurements if you're measuring.
That's true, and that's why this is no longer looking at measurements anymore. Because we're looking at this in terms of what numbers multiplied by themselves give us 25. So the answers for this, x, would equal 5 or -5.
Wait, what does the S stand for?
Side length.
The
Alright, write and solve an equation to find the side length of a cube with a volume of 27 inches cubed. So again, we're going to do this the same way we did number 3 up there, except now we're dealing with volume, which is the side length cube for a cube. So to find the volume, we would cube root both sides. And that would give us the side length equals the cube root of the volume. But we know the volume over there. It says that it's 27 inches cubed. So we can fill that in with 27. And we already know that the cube root of 27 is 3. So the answer here would be 3 inches for each side length. So in other words, the height is 3 inches. The width is 3 inches. And the depth or the length is also 3 inches. So yeah, that brings us to number 6, right? Now consider the equation x cubed equals 27 out of context. So just with numbers, is 3 the only solution? In other words, is 3 the only number that makes the equation true when substituted in for x?
yes.
Well, 3 times 3 times 3 is 27. That is true. But if we look at it like we did number 4, is -3 times -3 times -3 equal positive 27? No.
No.
So yes, this one means 6 means that 3 is the only solution for that.
Yeah, I know the answer.
So yeah, and then that's actually a good way to state that is for square roots, or for problems like number 4 where we've got an x squared equals 25, we've got 2 answers on those. For problems like number 6 where it's a cube root, we only get 1 answer for those. Alright, for number 7, we'll state the inverse operation we would use for these equations. Then we'll solve them.
Wait, number.
Alright, so the operation right here we're going to be using is the square root. Because this one is a square. So that means that if we take the square root of both sides, then we get x. But again, we're looking at this like we did number 3 on that last part. Is what number multiplied by itself gives us 100. That would be 10. Or -10. Because -10 times -10 is also 100. So on this one, once again, it's squared, so we're going to take the square root.
I could do an A for 6.
So we're going to square root the x squared and the 36 to get just the x. But again, this one is not a measurement, so we can look at this differently. What 2 numbers multiply to give us 36? 6. It's got to be multiplied by itself. 6 times 6, but also -6. Alright, 7c on this one. Now that it's cubed up in here, we're going to take the cubed root.
What is the cube root?
Cubed root. So, we're going to take the cube root of the x cubed, excuse me, and we'll take the cube root of 27. Well, this gives us x. So what number multiplied by itself 3 times is 27? 3. What about -3? No.
Wait, 3 times 3?
All right, 8. We're going to solve all these equations and we'll express our answer in simplest radicalist form if it's necessary. All right, so A, this one, again, we're going to take the square root of both of these. So x equals 8. But again, since we got an x squared right there, it's also negative 8.
So like for the test, is this all the work that we need to show?
All right, B, on this one, we're going to square root both sides. So in this one, we got to ask ourselves again, what number multiplied by itself gives us negative 64? So the immediate answer would be 8. But 8 times 8 is positive 64. Well, then we think, well, maybe it's negative 8. But negative 8 times negative 8 is also positive 64. So as it turns out, this one has no real solutions.
I like that way.
So what this means is that there are such numbers as not real numbers. We just don't have to worry about them in this class. It's a good question.
Sorry, I know you.
Yeah, if you guys ever see that, an x squared or a letter squared equals a negative number, automatically no real solution every time. Well, until you guys learn about not real numbers. C, again, we're going to take the cube root of these because it's an x cubed. So that gives us just x equals. 8 is a perfect cube, so that would be 2. Bam. So D, but this one's a cube root, right? So we take the cube root of both. So this would give us x because the cube root and the cube are inverse operations. So if we split this up, though, we could split this up into negative 2, negative 2, and negative 2. So this is the cube root of negative 2 times negative 2 times negative 2, which gives us a perfect cube of negative 2. So x equals negative 2. Now I did all the work on that. You didn't really necessarily need to. But again, that's how that is working. For some people, this one ends up being a little bit more difficult than it needs to be. But
Can I do it?
we can just take the cube root of both.
Can I do it for YouTube?
And x equals 1. What about negative 1?
No solution.
No, because
No
negative
real
1 times negative 1 times negative 1 is negative 1, not positive 1. So the only answer is 1. All right, on F,
Never works, but hey.
we're gonna. You can try.
Sal, I dare you to speak like height.
Thank you for that dare. All right, I'm just gonna go on anyways. So this is gonna give us an x. What is the answer for this one?
3.
3 and a negative 3. Very good. All right. On G, so you guys have some questions on this. We are going to take the square root of both of them. So x ends up being the square root of 5.
I knew it.
But also the negative square root of 5.
Oh, wait. But what would be the square root of negative 5? Would be the negative.
The negative cannot be on the inside.
Yeah.
Yeah, because then you're saying the area is negative 5, which we never really look at negative areas. Yeah, let's use the tree method on this one, right? So we're going to take the square root of both, which gives me the x, and that's great. But I need two factors that are the same of 10. Now the only two factors I get are 2 and 5 that are prime. They're prime, so we can't.
Square.
So it's not a perfect square. That's correct. So that makes the answer square root of 10, but also the negative square root of 10. Now there's a pattern with this. All right, is hopefully you guys by now realize that if we have a x squared equals something, we take the square root of it, but it's not just the square root, it's the positive and the negative value of that. No. All right. So on this one, we're going to take the cube root of the x cubed and also 15. 15, again, if we break this up, I get 5 and 3, both of which are prime. So there's no triples right there, so we're just going to keep it as the cube root. of 15, and that would be
Are you gonna look yourself?
Even if it does suck.
all right. On this one, once
No
again,
real solutions.
yeah, we're gonna take the square root of both, but we can't take the square root of a negative.
Wait,
All right, so let's cube root both of these.
but wait a
You're
minute.
gonna stand up comedy style.
Now this one is the cube root of a negative, which is okay. We can take cube roots of negatives.
You're telling me everything I know is wrong.
Now we need to figure out what this is though, right? Is it just, yeah, very good. If we split this up, we should get 8, 8, and 8. Very good, those are
Yes,
negatives.
you were right. You were right. You were totally right.
So the answer here is negative 8. That is a perfect cube. So on this one, we're going to take the square root of both of these. So that gives us x, and that's great.
Oh.
But the
I
8,
know, I
we
know.
need to split this up into 4 and 2. So it's really the square root of 4 times 2. And the square root of 4 is 2. And the square root of 2 here would just be the square root of 2. So we can show that we split that up, the square root of 4 times the square root of 2.
How did you get it a third time?
However, this is not the answer, because this is the positive answer. So it's this, and it's also negative 2 times the square root of 2.
What?
My hand looks like a girl.
So yeah, I didn't put the multiply right there, but it is 2 times the square root of 2.
It's 8.
On M, we're going to take the square root of both of these.
Get some narcotics.
I already.
So on this one, 45, we're going to split up between 9 and 5. 5 is prime, so 9 will split up into 3 and 3. Now this is a square root, so we only need a pair. So it's really the square root of 3 times a fiver. And this is our pair right here, so that's a perfect square, 3. And then we just have that square root of 5.
And also, wait,
So
you're
x is
not
3 times the square root of 5, but also, yeah, we have that second answer,
3 times the square
negative 3 times the square root of 5 as well. Alright, so let's do a cube root on these. So I'm going to take the cube root of x cubed, which is x,
I already solved it.
and a cube root of 250. So let's split this up. I got 10 and 25 on this.
Makes sense.
So 10 splits up into 5 and 2, both of which are prime. 25 is 5 and 5, both of which are prime. So if I reset this up, I got 3 5s, 1, 2, 3, and then the 2. And yes, those 3 5s make that a perfect cube of 5. Then we still got the cube root, rather, cube root
I did it.
of 2. So once again, we're looking at a cube root, so if we can find triples that are factors of 128, then we should be in good shape. So this gives us x, which is good. So finding the cube root of both of these. So 128 should be 4 and 32. 4 splits up into 2 and 2, both of which are prime. 32 would be 8 and 4, and 8 splits up into 2, 2 and 2. 4 splits up into 2 and 2.
Hey, look at that.
So it ends up being the square root of 1, 2, 3, 4, 5, 6, 7 twos. And yeah, that is cube root. Cube root.
But wait a minute.
So finding triples on this, I've got this set of 2s, 2. And this set of 2s, 2. And then I've still got the cube root of that last 2. And 2 times 2 right there is 4.
2 times 2 is 4.
So the answer here is 4 times the cube root of 2. Alright, on this one, we're going to take the square root of both of these. So that gives us 8, and that's good. But I've got the square root of 1 and the square root of 36 right here. So a should be 1 over 6. But remember, with these square roots, we should also have the negative 1 over 6. No,
No, just 1/3.
it's 1/3, yep. So if we take the cube roots, cube roots will only have one answer, so that's z. So this works just like the square roots, cube root of 1 and the cube root of 27. These are both perfect cubes. So z equals, cube root of 1 is 1, cube root of 27 is 3. R can be written a couple different ways. And this one is a square root, so we should have a positive and a negative answer. But I'm going to write 0.16 as a fraction 16/100ths square root. So this means I can take the square root of 16 and the square root of 100, both of which are perfect squares. So this gives us a y, and the square root of 16 is 4, and the square root of 100 is 10. But I can simplify this to be 2/5 or 0.4. But since it's a square root, I also have the negative of that value. So our actual answers are 2/5 and negative 2/5. Very good. So as it turns out, yeah, we're going to subtract 16 from both sides. What this does is it gives our x's, get our x's by itself. So that becomes a 0. We still got this x squared radicand. Equals 25 minus 16 is 9er. So we'll square root both of these. Then we get x equals 3, but also negative 3.
On the test, you have to put both.
Yep. Alright, on this one, again, we want the x squared by itself, so we're going to have to add 5 to both sides.
How small of it?
So this gives us 64,
Yeah, he does.
and this is 0,
How big are thy hands for that fish?
so I got a x squared. Now that we got x squared equals 64, we're going to square root both of these. 64 is a perfect square for 8, and also negative 8. Alright, good luck.
My hand looks like a gorilla.
Okay, so what you do, you would, oops. So you would divide 10 on both sides. Should be 144, and then this would cancel out, so it'd be x2 equals 144. And then the square root of 144 is 12, and that, so x equals 12. And then also, and then it'd be x equals negative 12.
Correct. Excellent work on that. So yeah, we do have the 2 answers there.
That looks sarcastic.
Alright, good luck.
Thank you. Thank you. See, what you do is you divide both of them by 2. You get x, whatever. You get x squared equals 8. From there, you can, you go square root of each, and you get 4 to 2, which is actually the square root of 4 times 2. 4 can be broken up into 2 2's, so it can go out here, and it can either be x equals 2 to the square root of 2, or x equals negative 2 to the square root of 2. And those go over there.
That is correct. Thank you. Alright, good luck.
What's up, guys? It's Matthew. So I'm gonna multiply the denominator of 2 by 2 and 32 by 2. So that gives you me y cubed equals 64. And then, so I do that by 3, do that by 3, 60. Wait, hold on. Yeah, 60. Wait, hold on. Okay. Yeah, 64 cube rooted equals
Too
4.
much talking over there.
So y equals 4 or negative 4.
Nice.
Boom.
All right, now since this was a cube root though, we should only have one answer on that. Which one is it?
Wait. Oh yeah, it's y equals 4.
Yep, just 4.
Hey, I'm human.
Wouldn't it be 8?
There we go. So this one, x squared equals p, where p is a positive rational number. So if we wanted to find the value of x, we would square root both of these. And we get x equals the square root of p. No. It would also be the negative square root of p as well, because we were looking at squares there, okay? So this one actually had 2 answers on it. Number 9er, this one's x squared equals 53, so this one says to estimate.
But those are, but 53's a prime.
Oh!
53 is prime, however, we can still take, we see that x is the square root of 53, or the negative square root of 53. So if I plug this into a calculator, I should get some kind of decimal on that though.
I don't have a calculator.
X equals, because it said to estimate, so 7 point, we'll just go to the hundredths. 7 point, alright, so 7.11 or negative 7.11. And that would be the answer on that.
Is it physically possible to
No,
do
B has a solution as well, so we're going to square root both of these.
Oh, the.
So that gives us A equals the square root of 15 or the negative square root of 15.
Right.
So to estimate this again, let's go to the hundredths. So the square root of 15 should be 3 point. So I'm just putting this in my calculator. I got 3.87, but also A equals negative 3.87.
The pinky was too long, that's why it looks like a French fry.
I don't know who got that, but we may have plugged that in wrong into the calculator. So it'd be 7.28 on those and negative 7.28. All right, let's take the cube root of both of these. So z is simply the cube root of 29, which again, we can put that into a calculator to find that out. So as an estimation, I got z equals 3.07 to the nearest hundredth.
Sweat.